Now we will see problems where we will ignore the air resistance, but the answer will be so weird. So, what is this air resistance? Before we start, in the previous problems you have seen, they have told ignore air resistance, ignore air resistance. Now, before we get into the topic, imagine you are, say, somewhat 100 feet above, somewhere over here in a higher platform. You will throw a stone of certain mass, certain size, and you will throw a ball of cotton of the same size. Okay, cotton. What happens? The density is more over here, the mass is more, the mass is less in cotton. So when you throw it up from up to down, the stone or the ball or a heavy object will always go down. The air resistance is ignored over there because it doesn't make much difference unless the winds are very, very strong. Whereas if it's a cotton, if it's lightweight, it's not going to fall at the same time. Why? Technically, it doesn't matter if it's a feather or a hammer. If there is no gravity, it must fall. Sorry, if there is no resistance, it must fall at the same time. But here, since air resistance is there, this will not fall at the same time. Okay, the ball of cotton. It's like dropping a paper. When you drop a paper, what happens? Air resistance will make it fly everywhere, right? This is the thing. Now, let us take a consideration of raindrop, a small raindrop. Let us see over here, if we ignore the air resistance, what happens? The question is, suppose a raindrop falls from a cloud 3000 feet above the ground, ignoring air resistance, how fast would the raindrop be falling when it hits the ground? If we ignore. Same thing what we have done in the previous problems is repeated now. So I will quickly skim through these. Initial altitude is given as 3000 feet, that is y of 0. Then initial velocity is 0. Why? Because it's not mentioned and it is starting from the 3000 feet up above. Find the vertical component of velocity from Newton's law. Now use feet, not meter per second. It is negative 32 feet per second square. And to find the velocity, integrate this. You will get minus 32t plus c. What is the initial velocity? 0. So when you substitute over here, the c value will be 0. So you can make the 0 and you will get this answer. I've not done that step, but we have done it in the previous videos. So you have to make t is 0, minus 32 0, and c will be 0 because y of t is 0, y dash of 0, sorry. Same thing now, start with the next thing, the vertical component of position, integrate this over here. When you integrate negative 32, what happens? You will get negative 32t square by 2, it will be negative 16t square plus 3 plus c. Now, y of t is negative t squared. Now, what is the initial altitude? When y of 0, t will be 0, but c will be equal to 3000. So, given over here, we write it as 3000. Okay, what next? Now over here, find the time when it hits the ground. That means, see, it starts at 3000, right? The rain drops somewhere over here in this cloud, okay? That is a very weird looking cloud, but just for understanding's sake. The ground is over here. The height difference over here is how much? 3000. So this is 3000. As it comes down, what is going to happen? The value of y reduces, it keeps on reducing and it reaches 0. So when y of t will be equal to 0, we need to find when it hits the ground, isn't it? So let's see, when y of t is equal to 0, for this equation, solve the time. How do we do it? Take out the calculator, mode 5 and 3. It'll be minus 16, 0 because there is no t term, and 3000. The answer is negative 13.69 or negative 13 points, sorry, positive 13.7 and negative 13.7. You can do this like this, or you can just solve it by taking this to the other side and taking the square root. It's up to you. It's the same thing. Answer will be same. Now you can see the answer is two answers. Time cannot be negative, so just take the 13.7. Now one thing before I forget, over here you have negative 13.2. Why is this? Because it's moving downwards. Okay, that is the thing. Acceleration is going downwards. So now we got the time. time at which it hits the ground. So from 3000 feet to reach the ground, it will take 13.7 seconds. Now, how do you find the total, the velocity? What is the velocity equation over here? Substitute instead of time 13.7. So that will be at the velocity at 13.7 means the velocity when the raindrop is hitting the ground will be minus 32 times 13.7. Let's do that now over here. So y dash of t equals minus 32t. So all you need to do is over here substitute 13.7 because that is the time it takes for the raindrop from the cloud 33,000 feet above to hit the ground at 0 feet. So now when you multiply 13, you will get this answer. It is minus 438.4 feet per second. Negative sign because it's going downwards. But look at this. Isn't it insane? Because the speed over here, raindrop, in terms of kilometer per hour, it is nearly 500 kilometers per hour. Just imagine the raindrop falling on your head or your body. It will be so painful. Why? Because it's nearly 500 kilometers per hour. Now, does it really happen? The raindrop, does it fall in this speed? No, the actual speed of the raindrop is just 16 kilometers per hour. Because of the air resistance, it reduces. But if air resistance is ignored, this is the case. But we cannot ignore the air resistance. So this is very important to know. What is it? That this certain things you cannot ignore air resistance. And the thing is the speed or the velocity reduces because of air resistance. In the coming section, we will see about Magnus effect or where air resistance cannot be ignored. So please stay tuned for the next video.